Hello. Hopefully you have watched the prerequisite day, which was completing the square. You've done your homework. We are now on to lesson one of this second unit. So I want to take you here because I briefly mentioned it before. So we have 10 lessons. That prerequisite was just a reminder because you haven't done completing the square in so long. So we have, this is like a variety unit. We've got conics, we've got some, and the conics is circles, parabolas are considered conics. We're going to do parabolas a totally different way. The formula is a totally different way you've ever seen it, and graphing it is different than you've ever seen it. And then we've got some notes on imaginaries, which works off of the quadratic piece. And look at lesson 6, average rate of change, which comes back, change in y over change in x, which you've done. But it's one of those pieces that just keeps going through every Algebra 1 geometry and A2, and they actually test on it almost every time. So we throw a little mini lesson in on there. So today we're going to go to circles, all right? And we're going to talk about domain and range of circles. So when you guys, let me look to see where I'm at with everything. So when you guys do this lesson, then you're going to, when we come back, I'm just going to kind of make sure that you've got your bearings with all this stuff. So there definitely will be some time for you to ask questions the next time you see me. Okay, so you have worked with circles and domain and range in past math courses, and the circles you did last spring. So I know that there may be some understanding, but it may be limited. So I want to really make sure we take a little time here. So this video might be a little bit long. And if you're stuck, you really need to watch the whole thing. I'm hoping not to make it terribly long, but it'll be a little lengthy. So, all right. Today we'll have a brief review of these topics as well as we'll come up with some up in future lessons throughout the course. So here's the formula for center radius form of a circle. And what it is it's the h and the k are the center, and that whatever this number here is really the radius squared. Okay, so you've seen this before. I know you've seen this before. So the domain is, when we look at the vocabulary words here, domain is all the set of input x values that you can use. So it's all of the x's, and x's, remember, is left to right. So when we look at the graph, we're going to look at it from left to right. When we do the range are all the y values. So it starts from, which are all like down to up, is how I'm going to have you do it. So you'll understand, because we're going to graph a circle, and then I'm going to ask, what is the domain? What is the range? And you can notate domain and range using set notation or interval. We'll talk about that as well, that's familiar as well, I'm sure, but you may not remember exactly what that means. We typically use something called the interval notation. Remember, with the brackets versus the parentheses? We'll go through it. So there's a lot of review in this. It's just a lot all in one. All right, so write the equation of a circle in center radius form. So that's that format, with the given center 1, -1. All right, so I'm going to just write that formula out for you again. This is a formula that you're going to have memorized too, by the way. Right, and you can see that this is my h and that is my k. It's the center. Okay, notice that, and it's inside the parentheses. Remember, I haven't said to you, but you'll hear me say it throughout the year. Inside a set of parentheses or inside a function is always considered the opposite. So that h is a 1. When I plug it into the formula, it's going to be a -1. And the y is the k is a -1, right? Which when I plug it in the formula, so it's like a negative k, so a negative, right? A negative -1 is going to be a positive 1. So when it goes in the function, the signs are opposite from what the center point is. And a radius of 3, excuse me. So the radius is just going to square, 3 squared, or 3 times 3 is 9. And then we're going to plot it. Okay, now I'm going to the domain and range is off of this. So think about how we're plotting this. So we start at 1, -1. We start at 1, -1, and we put the center. The radius is off, is from the center, correct? So if I'm going to plot 4 points when I go to plot it. I'm going to go 4 to the left, 4 to the right, 4 up and 4 down. Okay, when I do the left, I literally am going to say, okay, I'm going to go, did I say 4? I meant 3. So sorry. 3 to the left, 3 to the right, 3 down, and 3 up. So I'm going to go from the center, and I'm going to go 1, 2, 3 to the left. And then I'm going to go 1, 2, 3 to the right. I'm going to go 1, 2, 3 down. And I'm going to go 1, 2, 3 up. And then I'm going to plot, from those plotted points, I'm going to draw a circle. Yeah, not big. And no, you don't have to label it. It's only one circle on there. It's not like we have to any mystery on what the rest of them are. Okay, so it says sketch it, and then it says state the domain and the range. So the domain and the range, I mean, we could do set notation where they have inequalities. I'll show it to you once on this, but typically we use interval notation. So interval is the brackets, which means it includes the points, parentheses if it doesn't. So think about all the x values right now. So if I change the color right now, the lowest x value I go to is -2. The highest x value I go to is 4. So in interval notation, it is -2 to 4, right? If I want to use what they call set notation with the inequalities, we would write it like this. We would say x is anything greater than -2, including -2, and less than 4, including 4. But I'm going to tell you right now, I want the first one. I want the brackets. I want the interval notation. All right, so then we're going to do range. Now, range is the slowest y value goes to the highest y value. And it includes all those points in between. You can go to any y value in between, and you can touch that graph. So that's why I say it's all-inclusive. It's from the lowest to the highest and everything in between. So I'm going to go 1, 2, 3, 4. I'm going to go down -4. And I'm going to go up to 2. Now notice again, how did I get those numbers? I took the center, right, and I subtracted 3 and I added 3. Important to remember, because we're going to do it down here a little differently. And I'm going to go -4 is less than or equal to y, because it's the range, less than or equal to 2. And voila. Okay. So, now, first one done. 2, complete the chart below using the circle whose equation is. Now, I didn't give you graph paper here, okay? I want you to be able to come up with the domain and the range and the radius and the center without graphing. The center and the radius are not bad. All right, so since I just have a y squared, right? That you're making the assumption that the k value is going to be 0. Right? So your h and your k, remember, are opposites. So there's your h, -2, and the 0, right? Don't have a -0, just 0. So that is your center. And then your radius, remember, is here squared. So you're going to take the square root of 36, and that's going to be 6. Okay? Now, to find the domain is left to right, the x's. So you're going to come to the center, okay? You're going to go to -2, and you're going to subtract 6, because from the radius, right, correct, we subtract 6 to go to the left. So I'm taking the -2 and I'm minusing 6. So that means if I were to graph it, it would go all the way to when x is -8. And then I'm going to take -2 and I'm going to add 6, because that would be like how far I go to the right. So -2 plus 6 is 4. So my interval is -8 to 4. Okay? So you don't need a graph. Just work off the center using the radius. Okay? Now, range. I'm going to go to that 0. Range is the y. I'm going to minus the radius. I'm going to add the radius. So if I were to graph it right now, that would be my range value. Okay? All right. Now, here's where your prerequisite stuff comes in handy. So it says sometimes a circle equation won't be written in center radius form. So it won't be given to you like 2. When this occurs, you need to put it into center radius form first before you can identify its center and radius so that you can graph it. Okay, so for 3 it says write the following in center radius form, then describe the circle. When I ask you to describe the circle, I want you to tell me what is the center and what is the radius. You don't necessarily have to go with the domain and range. When they just say describe the circle, they just want the center and the radius. Okay, so that's going to be a homework question. All right, so here's my steps. Okay, the first one says group the x terms together and group the y. Think about why I had you do completing the circle right now. Do you see that there really are 2 perfect squared that will create a perfect squared trinomial, which means it's a binomial squared. Remember I kept saying that in the prerequisite video yesterday, which you should have watched. Okay, so you're going to group this. You're going to do x squared minus 4x, and you're going to leave a space because we have to create a perfect squared trinomial right there. Then you're going to do the y plus y squared plus 2y and leave a space. Okay. All right, so, and remember my constant, which is -1, is going to stay on the right-hand side all by itself. Okay, and then you're going to do your completing the square. I call it a partial completing the square because you don't use it to solve. You use it to set it up. So I'm going to take the b value for my x's, all my purples right now, and I'm going to look at only that. And I'm going to take the b, I'm going to divide it by 2, and I'm going to square it. You know what? I need to move this down because I'm going to run out of room. By 2, which is -2, and I'm going to square it, which is 4. And I'm going to add 4 here and to the right-hand side because it's an equation. Whatever I do to the left, I have to do to the right, in order for it to stay balanced. Okay, don't forget that. Then I'm going to come to my orange, which is my y's, and I'm going to take the b value, which is 2, divide it by 2, and square it. And I'm going to add that. Okay? So, from there, I created a perfect squared trinomial. Okay, so here is the next step you're going to do. What multiplies to be 4 that adds to be -4? And I keep telling you guys, it's that number. It's at x minus 2, and it's squared. For the y's, remember it's that 1, right? What multiplies to be 1 that adds to be 2, so that's y plus 1. And then this last one, the constants, you're literally just going to add them all together. And you're just going to get 4. Okay? So the -1, the 4, and the +1 add up. Make sense? Then what I want you to do is, remember it says describe the circle. So you're going to say the radius is 2 because it's the square root at 4. And the center, I can't undo this. The center is inside's opposite, so that -2 comes out as a +2. That +1 comes as a -1. And there, my friends, is your setup in a center radius form. That is the center radius form, and here is the description. Okay? All right, so go to page 6. Let us try this. Okay? Now, it says for 4, Bobby says that following formula is not a circle. Do you agree? Now, I can tell you right now that it looks like it might be a circle only because I see an x squared and a y squared. So see how I see an x squared and a y squared? So start thinking about that. If it's only an x squared, then it's a parabola. Or only a y squared is a parabola, because we're going to get into parabolas this year that are y squareds. If x squared and y squared they're both squared, the x and the y are both squared, then it possibly could be a circle, but we got to prove it. So we're going to set up our format, and I'm going to say my x's I'm going to pull together, and I'm going to leave a space. My y's I'm going to pull together, and I'm going to leave a space. It's a minus. And I'm going to bring this constant to the other side. So that's a negative 19. All right, and then you're going to start your process. Take the x, b, negative 2 divided by 2, negative 1, square. I'm going to add 1 here, and I'm going to add 1 here. The y's, the b value for the y is negative 8 divided by 2 is negative 4, square is 16. Add to 16, add to 12. Okay, now I can tell you already by looking at that right-hand side, does anybody see something? I've got a negative 19 plus a 1 plus a 16 gives me a negative 2. Now that's the radius squared, right? Can you square root negative 2? No. So that's why we say, is this a circle? Do you agree or disagree? But let's finish it. Let's set it up the rest of the way. So here is my result from taking these, right, and setting them up as factored form. Okay, and we are going to say, do you agree that Bobby says it's not a circle? And we would say yes. Bobby is correct. Cannot have an r squared value equal negative. Right? So that r squared value is equal to negative. You cannot have that. Okay? Simple as that to say. All right. We're going to do this a couple more times. Now, I'm gonna hesitate here. I'm going to let you do the next one. And I'm only going to put the answer up. Now, I will tell you right now, I gave you a little clue. This is a 0x, right? Because there's no x value, but there's a y squared minus 6y. I'm going to leave your space. Leave your space. I'm going to put 18. I'm going to give you a minute, and if I don't give you long enough, then hit pause on the video. But I'm going to give you a minute, and I want you to try that. Set it up. I want you to set it up in that format that we've been using, that center radius format. Okay? Take a minute. Okay, so hopefully you got x squared plus y minus 3 squared equals 27, because you added 0 here and you added 9 there, right? Now, if some of you did this, if you wanted to do that, I don't care. That's fine. If you like to have that 0 value there. But just know that when you did the creating the perfect square on the x squared, you took the b value, which was 0, divided by 2 and squared it, so that means you're adding 0 to both sides, okay? All right, so now this is a little tricky one. So we have the center. to be 0, 3, and we have the radius to be the square root of 27, and I'm sneaking a peek because I can't remember. It was 5.196. So when you graph this, it's kind of weird, right? Because that's not an exact. So you're going to do 1, 2, 3, 0, 3. And you're going to go up five, like just a little over 5 and a little below. Like, so you're going to go 1, 2, 3, 4, 5, plus a little bit more to the left. Like a little, just a little past sugar roasted peanuts. 1, 2, 3, 4, 5. Just a little bit. It almost looks like half. 1, 2, 3, 4, 5. I can't get it perfect with my stylus, but 1, 2, 3, 4, 5 down. A little over that. 1, 2, 3, 4, 5 up. A little past that. So it's just over the graph. I don't anticipate that they will make you graph one of these on the regions. And if we had you graph it on a any type of assessment, I wouldn't do that crazy one with you. Okay. All right. 6. So this is your last one because I'm not going to do 7 with you. And it's not on your homework. I checked. And it's not one that we put it in there. And I'm going to make a note if I can, if we have time during our next live session, I'm going to talk to you guys about that one, but I'm not going to do it in the video. Okay, so 6. Now, it says we've got point A is 3, 2. And the center of the circle is -2, 3. Okay? They want the radius. This is a formula you learned last year, and it's called the distance formula. And so it's given 2 points. Change in the x's squared plus change in the y's squared. And if anybody remembers, it actually is derived from the Pythagorean theorem. But you don't have to know all that. You do have to know that formula in case it pops up, though. So we're going to say this is x2, and this is y2, and then this is x1, y1. And then you're going to plug it in. So we're going to do 3 minus -2. Did you notice that? Don't drop that negative. So it's a -2, and it's a negative formula, so the 2 negatives make a positive. If you don't want to write that negative and just put 3 plus 2, totally fine. I'm pointing it out here, making it obvious to you here. You don't have to do it that way. y2, 2 minus 3 squared. Okay, so 3 plus 2, we decided, right? 2 negatives make a positive. 3 plus 2 is 5 squared is 25. 2 minus 3 is 1, -1. -1 squared, and -1 times -1 is just 1. So this is one of those wacky numbers. It's not a perfect square, but we just found the distance, right? Here is your distance. So the radius for this circle is the square root of 26. Now, if you were to put that in the formula, like if I had you set up the formula, then you would actually, when you square the square root of 26, actually, let's do it. What if I said to you, tell me the, put this in, given this information, put this in center radius form. So you would say, all right, you would square the square root of 26. When you square a square, when you have a square root and you square it, it actually comes out of its square root. So that would be 26. And then the radius, the center is x minus 2. So remember, it goes in the formula as an x plus 2. And then the k value is 3, so it goes in as a -3. So if I asked you, if I took that a step further and I asked you to write the formula for that, you would do that. Okay? All right, guys. Hopefully that helped. It was a lot review, basic, most of it was review. We are going to get into next week where we start to do the directrix and focus, but I'm going to do that with you live because it's brand new and it's a different way to do a parabola. So do the homework for this, submit it for me. Submit it for me. If you have any questions when you come back, you can ask me. Okay? All right, take care.